We will now solve problems using the conditions of equilibriums we developed earlier in the lesson. Let's start with this simple problem. A uniform meter stick pivoted at its center has a 100-gram mass suspended at the 25 centimeter position. At what position should a 75-gram mass be suspended to put the system in equilibrium? What mass would have to be suspended at the 90 centimeter mark for the system to be in equilibrium? Well, let me see if I can show this arrangement to you. Where here I have pivoted a meter rule at its center of mass. Now the center of mass is about 50 centimeter. This is the pivot point. If I apply a force on the right, it is going to rotate about the pivot point. And axis, you can see I just touched it and it sort of began to rotate. Now what is given? A 100-gram mass. I have a 100-gram mass here. It is suspended from this 25 centimeter mark. Now starting from here at 0, 10, 20, and I'm going to suspend this at the 25 centimeter mark, and there it is. This is the 25 centimeter mark. Now in order to balance it again, we need to find the position from where a 75-gram mass has to be suspended. I have a 75-gram mass here. Where should it be suspended? That's the question we need to answer. Well, let's figure out where that is going to be. That's too far. Am I getting a balance there? Almost. I've got the balance. So you need to suspend the 75-gram mass from, let me read, I got the 80 centimeter mark, the 80 centimeter mark. Now, I decided to show this to you to talk about it. You can see what is happening now. If you take the torque of all the forces, tell me what are the forces acting on this meter rule? The weight of the meter rule is acting vertically down at its center of mass, and the normal force applied by the pivot is upward, and those two forces actually cancel. Then there is a force pulling the meter rule down here, the force due to this 100-gram mass. What is that force? The weight of this 100 gram. That means 0.1 kilogram times 9.8. So this is 0.98 Newton. And here is, we have 75 gram at the 0.80 centimeter. Tell me, what is the torque of this force, the 0.98 Newton, about an axis through the pivot? What is the torque of this force about an axis through the pivot? It will be that force multiplied by this torque arm, which is, this is 25 centimeter mark, the center of mass is 50 centimeter, so the distance is 25 centimeter. So 0.98 multiplied by 25 is that torque. Now tell me, is that torque a clockwise torque or a counterclockwise torque? When you are looking at it, I'm going to stand the way you are going to look at it. So the torque of this force will be, this is the pivot point. it will be rotated, look at the way my hand goes, in the clockwise direction. The torque of this will be a clockwise torque, 0.98 multiplied by 0.25. Alright, what is the torque of this force? Now the mass is 0.075 kilogram, multiply that by 0.98. That will be the force. What is the torque arm? This is the 80 centimeter mark. The pivot point is 50 centimeter. So 80 minus 50 is 30 centimeter. The torque of this force will be the force multiplied by 0.3. What kind of a torque is this? This is the pivot point. The torque will be counterclockwise. So if this is a positive torque, this is a negative torque. Tell me, what is the torque of the weight of the ruler about an axis through the same point? The torque of the weight of the ruler and the reaction force, both that will be zero because the torque arm is zero. There are only two torques. Therefore, sum of the torques, you can solve this problem by setting the sum of the torques equal to 0. Alright, let's do, here we have the meter rule pivoted at the 0.5 centimeter mark at its center of mass, at the pivot at A. Let's mark the different forces acting on the meter ruler. What are the forces acting on the ruler now? The weight of the ruler will be acting vertically down. And what is the weight of the ruler? It will be its mass times acceleration due to gravity. The weight of the ruler, mg, will be acting vertically down. And the normal force, Fn, will be acting vertically up. Well, the weight of the 100 gram, where is the 100 gram suspended from? From the 25 centimeter mark. And what is the weight of the 100 gram? It will be 0.1 kilogram times 9.8. 0.98 Newton is acting from the 0.25 centimeter mark. And now we have to find the position from where a 75 gram mass to be suspended on the other side so that the ruler will balance again. What is the weight of the 75 gram? 75 gram is 0.075 kilogram times 9.8, that is 0.735 Newton. And the 0.735 Newton is at the point X. And we need to find that point X. Okay, now all these forces are Y forces. So we apply the conditions there, the sum of the Y forces, which is Fn upward minus 0.98 minus mg minus 0.735. Now this is the sum of the Y forces. There is only one positive force upward, that's Fn. So Fn minus 0.98 minus mg minus 0.735 must be equal to 0. This is summation of all the Y forces equal to 0. So that is one condition. Okay, but that will not solve our problem, does it? We need to find the value of X. Now, we now choose a point so that the torque of all the forces about this point may be taken. Now, we have several points here. The end of the meter rule, the 0.25 centimeter mark, 0.5 centimeter mark, that's the pivot point, the X centimeter mark, and the 1 meter mark. Now tell me, which of these points is the most convenient point we can take the torque of all these forces? the most convenient point is the point through which maximum number of unknown forces are passing. If you now notice the force mg, we don't know the weight of the ruler. Mg is an unknown force. Fn, the normal force, is an unknown force. And both these forces pass through A. Therefore, an axis passing through A is the most convenient axis. Why? Because the torque of mg about an axis passing through A is 0. The torque of Fn about an axis passing through A also is 0. So, the best choice for this purpose is a point through which the maximum number of unknown forces pass. And that is point A, because both mg and Fn pass through A. That means the torque of mg, the torque of this force mg about an axis passing through A is 0. Why? Because the torque arm is 0. Similarly, the torque of Fn about an axis that passes through A is 0. What is the torque of 0.98 Newton about an axis passing through A? It will be the torque arm, which is 0.5 minus 0.25. Is that right? This distance is 0.5 minus 0.25. That is the torque arm. Multiply that with the force, that is 0.98. And that is 0.245 meter Newton. And that is the torque of 0.98 Newton about A. And is that a clockwise torque or a counterclockwise torque? You can see this force will rotate the ruler in a counterclockwise direction. Therefore, that torque is positive. Now, the torque of 0.735 Newton. What is the torque of this force about an axis passing through A? It will be, what is the torque arm? This is x centimeter mark. This is 0.5. So that distance will be x minus 0.5. That is the torque arm, multiplied by the force 0.735. The torque of 0.735 Newton about A is the torque arm x minus 0.5 times 0.735. And that torque is a clockwise torque. And a clockwise torque is negative. Is that right? A clockwise torque is negative. Alright, very important to identify the sign of the torque. Now, summation tau equal to, what is the sum of the torque? Adding the two torques give you 0.245 meter Newton minus x minus 0.5 times 0.735. Add the two torques and that must be equal to 0. And now this is a simple equation that contains only one variable. You can distribute that. That will be 0.245 minus, see, you got to multiply here, minus 0.735x. And these two minuses will make it positive, plus 0.735 times 0.5 is 0.3675. So distribute and now simplify, and that gives you x equal to 0.83 meter. The 75 gram mass will balance the ruler when it is placed at 0.83 meter, which is 83 centimeter. Do you remember